and go.
Good afternoon. My name is John Elmore, Regional Sales Manager for Lumenis Lasers. We're currently going to do a quick in-service on the UltraPulse Encore CO2 laser, incisional and fractional handpieces. Moment on laser safety. The primary concerns that we have for any laser are going to be ocular and fire hazards. In order to protect the patient and staff from stray laser light to protect the eyes, the users will wear safety glasses. On these safety glasses will be the wavelength as well as the optical density. CO2 laser would be matched with this. The wavelength would match on the back of the laser, which will also correspond to the glasses, which as well will correspond to the laser safety sign, which will be placed on the doors. We'll more to that later. For patient safety, if the patient's in the process of having a bleph, we'll use corneal shields. If we're doing a resurfacing, the patient will be wearing the eye shields that are provided, similar to tanning goggles for reference. If the patient's awake and we're doing any kind of oral or facial procedures when we're not around the eyes and the patient's awake, the patients will wear glasses. If the patient is twilight sedation or asleep under general anesthesia, we will tape the eyes shut and use moistened 4x4s over the eyes. We replaced a engineering protocol and control with an administrative control. The laser will say danger, which wavelength, the hazard will be placed on the door. This will only be used when we're doing an actual laser case. When we're not doing a case, we'll either take the sign down or put the blank side out. This will match the wavelength. Different lasers have different optical densities and optical properties and different hazards. If we're doing such, the signs will be posted. Another hazard to any kind of surgical field is the danger for smoke. There has been found viable DNA in smoke plume, whether Bovi, ESU, or laser. So if you are smelling it, you're ingesting it. First line of defense would be a laser mask, would usually your silver or black. The best protection would be to use some sort of smoke evacuation. If you're using wall suction, which is not advised, you would have a carbon filter which would absorb the heat. A smoke evacuator either made by Buffalo, Surgimetics, or any one of a number of manufacturers, or Neptune with the proper filter inline tubing. Tubing is PVC, so if it's extended into the field and the laser hit it, it could burn. So it's another thing to be aware of. Moving on to handpieces. For most incisional work, we'll use a focused incisional handpiece. It will come in a 1 millimeter or a 0.2 for the purposes of blephs. We'll use the most fine, which would be a 0.2 millimeter spot size. This will be in 3 components. You'll see within the tray that you have the stylets, the nose cone, and the focusing lens. For the purpose of this illustration, I'll start with the larger one. It'll be easier to see on video. The lens is the focusing lens, which will attach to the laser. We'll do that in just a second. This has a lens in it. It is blue or black. We will not flash this device. It has a lens. It doesn't react well to extremes of heat or cold, and these do not bounce. This is about an $800 item, so try to keep it from being dropped. The nose cones are aluminum. The stylets are stainless steel. One goes in as such. This will thread on. And this will attach to the laser arm. For fine work, bleph, incisional work, the 0.2 millimeter spot size will give a finer spot. It's primarily for blepharoplasty. Sterilization, follow the manufacturer's instructions, and this is according to the sterilizer. Typically, since it has a lumen, it would be a 10-minute cycle. Again, this too has a lumen. It threads in, and we'll come back to these in just a second. There are 2 other handpieces that we'll show. These are going to be the ablative and fractionated handpieces. So the UltraPulse computer pattern generator, we also call it the CPG. This device will take a single spot, convert it into a pattern, and it'll lay down a pattern, therefore the computer pattern generator. It has an electrical input, and threads to the top of the laser, and we'll assemble these shortly. This is a two-piece function. The nose cone, which can have its smoke evacuation hooked up to the back. This device will be cleaned with a standard operating room disinfectant, again with note to not get moisture or fluid in the electrical connector. This assembles as such. This will thread in, locking down the nose cone, and then this will be attached to the laser with the electrical cord being attached. We'll come back to that in just a moment. The other handpiece being the Deep FX, and the Deep FX has a protective cone that will be removed. A disposable tip will be placed on its place when we go to use it. I'll leave it on for the time being. This too will connect to the laser. These are both blue and black, neither of which will be flashed due to their electronic and lens properties, and it too has an electrical connection as such. We'll put those on in just a moment. Moving over to the laser itself. You need probably pan over this way, Doc, if you would. Laser has a small footprint. We're going to start on the back. There's a handle back here to move, as well as on the front, so we can pull it or push it. Purposes of what we're going to be doing with this Inservice, we're not going to talk about the puffer. The laser cable cord, the standard 110, is wrapped around. We have a circuit breaker down below. If the laser is turned on and nothing happens, check the circuit breaker, make sure it's plugged in, make sure there's power to the wall, and then check the circuit breaker. Plug the laser in over standard OR plug, 115 volt, 20 amp circuit. Foot switch piggybacks on the back, placed in front of the operator so that the doctor only can use the laser. And we'll move around to the front. The laser articulate arm has 19 mirrors in it from the base of the unit up through the top around. The latch locking mechanism releases at the top. There is a gate here at the back. And the laser arm should only be removed and deployed out the back of the laser. There are two identifying markers on the arm, up arrows indicating the correct direction of orientation, and as well as at the end, the arm will swing out and down. If for whatever reason the operator has to take the arm out the top, the alignment of the lenses will not work and it will not give it a good therapeutic effect. The arm is counterbalanced by the weight on this side of the arm. The nut is released and the weight is moved inboard or outboard depending on the need for balance. Different handpieces will have different weights. The arm needs to be secured and then the weight locked in place. If not, the weight will slide, causing the end of the arm to shoot to the ceiling, possibly damaging the laser or other components, lights, etc., and booms that are available in the OR. We're going to attach the handpiece to the arm. Common practice is to attach the lens to the end of the articulated arm, threading it on. The non-sterile person will hold the arm while the sterile person advances the drape. That will continue. The non-sterile will continue the arm with the arm now sterile. The sterile person can take the fenestration off the end of the drape using either a laser arm drape. I've seen an arthroscopic drape used, or as well as a orthopedic camera drape. With the threads exposed through the drape, the nose cone is then threaded on. The laser arm is now sterile, and again, since I've added weight to it, I will change the counterbalance just a little bit so that the arm has a slightly positive buoyancy and will float up and out of the field as opposed to down and into the sterile field. And with that, the laser arm should hang appropriately when the doctor's not using it or out of the way. The two other hand pieces we'll go ahead and connect now. computer pattern generator. Again, these are fairly expensive. They are not designed to bounce. So adequate care in handling is recommended. With the electrical connector, the scanning cord and cable, again, red dot lines up with red dot. They'll only go one way. To remove, lift up on the strain relief, and then remove the electrical connector cable as such. You'll click in, it only goes in one way. Well, we'll see that this is much heavier than the incisional handpiece and will weigh. Found that if you just support the arm lightly, extend the outbound outward on the weight, and again reach a balancing point, and the arm should just slowly achieve its own balance point. To disconnect the CPG, now I like to do this with the laser off so that I don't risk blowing a fuse if the laser is connected with it out. Those are the older rules. Till proven otherwise or told otherwise, we'll turn the laser off, connect the CPG and or the total FX. If not, a fuse might blow. On thread, being conscious that the arm will now be slightly unbalanced, and it will, if it let go, shoot to the ceiling. So I'll just let that stop at that point. Put the case, device back in this handpiece case, and then we'll pull out the deep FX. This is for larger, deeper, fine lines and wrinkles. So showing you how that works. Can we edit that out? All right. Again, blue or black. This will thread on to the handpiece. The weight again will be slightly buoyant. The electrical connector will go on. Again, red dot to red dot. Keeping fingers off the lens. When you go to clean this and wipe this down, do not use your abrasive hand pieces to clean the lens. There is lens paper, and it's recommended that you use methanol alcohol to clean the lens as you would microscope lens or camera lens. Very good. So moving to the front of the laser, you'll see that there is excuse me, that there is a touch screen and a key. I'm going to turn the laser on. It's going to take about 45 seconds to a minute for the laser to calibrate itself. You'll hear buzzing, some clicking, some chirping, a couple pops and a buzz, and as it calibrates itself to make sure that there's adequate power it's creating to measure how much it's delivering, it'll keep the laser from, it will give you exactly what you're asking for. This will take 45 seconds. From this point, oh, okay. All lasers are required to have an emergency off switch. Typically, to shut down the laser, we'll use the key to let it go through its shutdown cycle. If there should be a code, a fire, or any other calamity, external or internal, depress the red button. This will spring activate itself, so when you go to turn on next time, you don't have to reset it. With different handpieces, the laser will identify that this is the Deep FX scanner. On the screen, you might want to get closer or zoom in. You'll see that on the screen that we have choices of aesthetic, ENT, GYN, neuro, and general surgery. For this case, or in most cases we'll be doing in this in-service, we're going to be using the aesthetic key. And what will happen is the laser will know what device is attached to it. It'll come up and give us our choices of treatment. And in this case, since we are using the Deep FX handpiece, we will use the Deep FX icon, and the laser will then give us different choices of what we're going to be doing. In this case, we have different choices of shapes: square, circle, diamond, rectangle. This will tell us the size from 0 to 10, our presets, which I will not go into, and the density. And the density is how closely the spot size are located. And again, by doctor direction, we'll increase or decrease the power as required. And then moving on to the rate. And this one currently is set at its default. Again, these are part of the prescriptive process, which the doctor will dictate what he's using. I will change handpieces to show the CPG screen, and then we'll go directly to the incisional handpieces. All right, I've just recently attached the CPG. I've attached the electrical cable as well as the connector to the articulated arm. As the laser finishes, it's self-diagnostic, telling me that all is well. As the laser comes up, if I can get you to focus on the screen, we'll see that we come up with energy per pulse. Our usage for energy will toggle up, toggle down. Energy per pulse. And then our patterns. A typical pattern setting might be a 3, a 5, and a 1. In this case, it would be the shape of a square, size 5, and an energy density of 1. And again, this is part of the prescriptive process, but this basically tells us that we're going to lay down a diamond pattern, that this is a size of a 5, and that we're going to put the spots about 10% apart within that given area. I can change the sizes, or change the shapes to diamond, to a 6-sided box. I can go up to a line, a rectangle, or a triangle, or an annulus. I can increase or decrease the size depending on the power. If I'm using a larger size and I have to go up in power to achieve the densities. And again, this tells me how close or how far apart. Every doctor will have its own particular comfort level and preferences, but a normal or a usual setting would start out with a 3, 5, 1. Physicians will have their preferences, and that will change from time to time. Laser commands are laser ready, laser standby. Laser off is turning the laser off. Laser on, the laser is already on. So the commands are laser ready, laser standby. If the operator of the laser, physician, is not actively engaged in using the laser, we will take the laser and put it in standby. Operate the laser in the most cautious and safe manner. Across the top, SurgiTouch software allows us to go back to where we covered earlier. Aesthetic, GYN. The ultra pulse mode will not come up in this with this device on. Well, it will, but it'll set it back to 0. Continuous mode will not function. The options screen will go into a later date, but this will increase the aiming beam, decrease the aiming beam, increase the volume of the audible sounds for the laser, and then there's a whole bunch of different diagnostic capabilities that we'll not go into in this Inservice. Moving back to the SurgiTouch software. The last thing I'll do is do the incisional handpieces. Okay. Now, I've just removed the CPG and the Total FX handpieces. I now reattached the incisional handpiece that we showed earlier. I'm just going to slide the stylet up, take the cord out of the way, and imagine that this is now draped in a sterile manner. You'll see that I have a nice round circle. Typically, before we'll use any laser, we'll want to test it over the back table with a wet towel underneath and a tongue depressor. And all we're looking to do when we test the fire of the laser is to make sure that the therapeutic beam as well as the aiming beam are aligned. Since CO2 is not visible to the human eye, we use an aiming beam to let us know where the energy is going. On the touch screen, we'll go back to aesthetic. We'll use Precise FX or Incisional FX, doctor's choice. And then you'll see a red exclamation point, and it reads, and you can't see this on the screen, you can't see it on the video, but down here it will say make sure that the correct delivery device is attached. And it's wanting to make sure that you know that you have an incisional handpiece, and we're just doing an intentional check. He'll press the check mark, and it'll go forward. The doctor will say, I want the laser set at 5 watts on continuous mode, or if he's choosing ultra pulse, he could press the ultra pulse button, which will pulsatile the laser energy, and then it'll have energy per pulse, and he'll say I wanted it anywhere from 50 to 225 pulses per second, energy millijoules per second, or the laser energy up to 60 watts. And that's probably enough in this Inservice for that. Again, this is part of the prescriptive process, and again, the laser energy will be delivered at a 0.2 millimeter spot size, since we are in fact using the 0.02 millimeter handpiece. So a couple other points to remember when we're passing anesthesia gases. We're beyond the days of ether. However, we're now using polyvinyl chloride tubing. We want to make sure that we're intentional in protecting the airway. Typically, we're using high concentrations of oxygen. If we're doing an upper airway case or a bronch or any kind of oral or suspension laryngoscopy procedure, we'll want to make sure that we use a laser endotracheal tube from either Mallinckrodt, Zomed. I think Roush makes one now. You'll read in the user's manual that they're only slated for CO2 use, not 532, not Nd:YAG, not Homium. But for general external procedures, as the anesthesia tube comes out of the mouth, we want to protect the circuit. We'll cover it with wet towels, being intentional when we're working around the labia or the tongue to make sure that we don't inadvertently ignite the PVC. If we are doing an upper airway case or in the nasal pharynx, we want to cut our FiO2 down to room air. I want to make sure that we monitor the sat rate so that as the patient is not on high concentration of oxygen, it doesn't compromise the case. Around the surgical site, when we're doing a facial procedure, we want to have wet towels around the face, protect the hair. Hair does catch on fire. So when the doctor is doing any resurfacing around the hairline, we want to pull the hair back, make sure we have a wet towel so that we can feather in the cosmetic approach nicely in the hairline as well as along the jawline. And I think that concludes it. So a little special end for our anesthesia friends.
In the event of an airway fire, any specific recommendations for?
Well, typically for most laser protocols, we'll have a basin of water on the back table. We're going to prevent airway fires. So the first thing to do is shut off the O2, call 911. And again, after that, it becomes saving the patient. The key on all operating room protocols for fires to have a plan to make sure that everybody knows exactly what they're doing and when and how, and so we don't have one person heading for one door, one person heading for the other while the patient smolders. There are very, very few laser fires in the OR because we're intentional and we do lots of in-service to protect the patient. But fire hazard is fire hazard. So in all lasers and all electrical components in the operating room, know where your fire extinguishers are. Brace, all the standard precautions. So, any other questions?
Anything else as far as anesthesia pertinence beyond that?
Nope. Just communication between physician, anesthesia, circulator, and tech.
Thanks very much.
Very good.